What's up, math scholars? It's a rainy Monday, so everybody's super energized today. We are learning 5-day 1, solving equations. Today, the variables will be on both sides of the equation, so that's what will be different. So who's excited to learn some math? All right, go ahead and jot it down, and then we'll talk through the strategy. We'll do this one together. Something, Anthony's already working ahead because he's a scholar. He's like, something weird's about to happen. And he's right. What's going to happen with the 8 and the negative 5x? Combine into being a 3x. And then you have to get your x's together on one side. This is something we haven't seen yet. So I need to get this 3x over to join that 3x. So I'm going to do a minus 3x. What's going to happen now?
10 equals nothing.
Dun, dun. Yeah, 10 equals nothing. There's nothing left, like 0 x's, 0 apples. Is that a true or false statement?
False.
That's a false statement. What that means mathematically is there is no solution to this problem. So we started off this Monday with a unique challenge that really made our brain think a little bit. There is no solution to this.
Good job, Anthony, for being a scholar.
Good job, Anthony. All right, go ahead, jot this one down. We will do it together, and then I think we'll be ready for board buddies after that. We do have x's on both sides of the equal sign. So I always have the advice for my students to move the smaller term that has the variable to join the bigger one. So what I mean is, like, this is a negative 8x, and this is a 4x. Which one's smaller? No, negative 8 is much smaller. If you think of a number line, negative 8 lives way down left of 0, but 4 would live up to the right of 0. So this is your smaller term. If you always are moving the smaller to join the bigger, you'll avoid working with negatives more often. Okay. So I would move this over to there. Do you know how I would move it? Very good. So at that point, I'd have my 7. This would be gone because it has moved. This together would be a 12x, and then this would be that negative 17. It's a little weird. We're going to have our x's on the right and our numbers on the left, but that's okay. Who thinks they know the next step, Caspian? You would. You're right. She is such a scholar. And then that's going to be 24. Jose, what's going to happen last? Very good. Now, when you're doing this on your paper, Jose, are you showing every work straight down like we're doing? Step 1, right here. Step 2, right here. Step 3, right here. It's going downward. It's so important to show it downward so you can literally see every single step that happened. We're getting into problems with more and more steps than we saw last week. Hey, question. Well, the answer is 2, but how could you check that you got that answer right? Anthony?
Plug 2 in for x.
Right, so I always do a little check mark when I do my checking. Check mark. Is 7 minus 8 times 2 going to equal 4 times 2 minus 17? Not sure. Might need the calculator. This would be 7 minus 16. Can you do 7 minus 16 in your head? Negative 9. And then 8 minus 17. What's 8 minus 17? So that means we did it right. And I do another check mark to show we did it right. So you don't have to check all of them, but it's definitely a good recommended strategy if you're doing a quiz, you know, and you get done early. There's no prize for turning in your quiz first, is there? So check your answers, you know? Okay. All right, so last week we learned about the fraction clearing technique where we multiplied by the reciprocal. However, if we would multiply by a reciprocal right now, we would multiply by 4 over 1. The 4 over 1 would have to distribute to this stuff. So honestly, I probably would just distribute the 1/4. It would be done with the 1/4. So if you need your calculator, you can use it. What is 1/4 times 16? You could do it in your head. It's 4, so at least one person can do it in their head. Because it's 16 divided by 4, basically. Sorry, I probably didn't give you enough time to write it down. Wait, I'll slow up a little bit. All right, what is that 1/4 times the 60? 60 divided by 4, basically. What is it? 15? Who thinks they know my next step? Okay, so you can move the 5 next. I'm not going to stop you from doing it. However, what I always prefer is to get the variables together first. So I would move the smallest term with the variable. Who's smaller, the 9 or the 4? So I would move the 4 to join the 9. So I don't know if you guys all heard, Anthony wanted to move the 5. That would have been fine. I just try to get my variables together first. It's just it's the mathy teacher thing to do. 9x minus 4x is 5x. Now what do you guys think should happen next? Jose? Add the 5, yep. Get 5x equals 20. And what's my last step? Caspian. Good. That was a lot of steps to that problem, wasn't it? Let's count our steps. Distribute 1, move the 4x 2, move the 5 3, divide by 5. We're into 4-step problems. You guys are turning into little scholars right before my eyes. Do you have any questions? All right, people in the video, we're going to send some board buddies up. Here's our first problem. If you're watching at home, hit pause and maybe try it by yourself. All right, this was a great first problem to call you up to do. Jose asked about the numbering. I'm sorry, it was awkward that they numbered number 1 like that because it looked like 1.24, but it's just number 1. You add your 3m to join the 5m, you get 8m. And please show this step. You divided by 8 next. And then you get the 3. Okay, just show all your steps. That's what the math scholars do. All right. So this is number 2, and then this is the problem, okay? Alrighty, so I'm actually glad, I was making fun of this group's handwriting, but I'm actually glad they did what the math teacher in me would suggest, and that's taking the smaller c to join the bigger c first. So they subtracted their c over, got 3c. They added their 7 over, got 27. And finished by dividing by 3. Now this group did not take my math teacher suggestion. They added their 7 first, and then they moved their c. Guess what? Still got the same answer. You don't necessarily have to take my suggestion, as long as you get all the variables together and all the numbers together, and then you divide to finish. Okay? So good job if you got 9. How did we do at our seats? We are all still doing these at our seats?
Of course we are.
Of course we are. Okay. Alrighty. Oh, tap. All right, everybody look up here. This one was definitely a challenge because as hard as you tried to avoid negatives, you just couldn't avoid the negatives. Your final answer ended up being negative. So my suggestion is always move the smaller variable, the one that's smaller. And there was some talk. Is -3 smaller or is -2 smaller? -3 smaller. So you'll see this group. They moved the 3k over to here, and this is actually where this group messed up. They told me that -2 and +3 was -1, but I corrected them. It's a +1. Then the 17 has to subtract over and gave them a -8. Now, why did you guys divide by 1? You never have to divide by 1. It doesn't really do anything. So you were done right here, actually. K equals -8. Okay? Exactly. So we're good? Ooh, got some distributing this time. This one was kind of hard for this person to keep their handwriting nice because of the Z's. I don't like when problems have Z's or T's because Z's look like 2's and T's look like plus signs. But if you want your Z to not look like a 2, you could do the math teacher thing, and that's like put a little crossbar through it.
Or just use X.
I never used to put crossbars through my Z's until I became a math teacher. Or you could just replace all the Z's with X's. That would be scholarly. That would work too. So we're going to distribute the 3, so it's going to be 6z minus 8. Now the math teacher advice would be move who? Move the smaller term that has the z. So we're going to move the 5z to join the 6z. That's -2 equals 1z minus 8. And then you're just going to move your 8 and you're done. So this group had the right answer. Their handwriting with their z's was just a little sloppy. I wanted it to look nicer, so I redid it. Okay. But they got the answer right, so I will let you know they did get the answer right. So good job.
By myself.
By himself. Boom. Okay. Oh, all right. I was like talking about freshman football and getting myself super distracted, but my board buddies were 4 for 4. Every single group got it right with no teacher help. I'm proud. Okay. You get your 5A minus 15. They even did what I would have suggested, moving the smaller one to join the bigger one. That's a 9A. Move the 15 to join the 3, 18, and divide by 9. Looking great. Everybody get 2? Everybody still doing it on their paper if they're not on the board?
Yes.
Okay.
I have 2, 4, 5.
Oh, it's shake. Look how much it's shaking. Oh boy. Well, let's see how you do. Bring up your calculator if you need to. I probably would suggest distributing that 2/3 in. Oh, I don't know. I hit record. Great job to all our board buddies getting their 4 on this one with distributing those fractions. All right. Okay. We are on the video right now. We have 2 word problems. We're doing them together. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of used cars sold? Ooh, so this is going to be quite the equation we're going to have to write out. Kenneth, do you have an idea of how we can write this equation out? Okay. I'm going to write old cars, or new and used is what I'm going to write first. New and used. And we want to know when the new cars will be twice the number of used cars. So we want to know when new will equal twice used. But what do you know about new, Kenneth? And how many is it right now? It's 78 and increasing 6 per year. We'll just have X be years. Does that look about right?
Yeah.
78 increasing 6 per year. Okay. How about, what do we know about used cars? And what's happening each year? Decreasing by 4 each year. So we want to know when new will be twice the number of used. Does that look okay?
Yeah.
You're my first Algebra 1 class of the day. You need to make sure I'm not messed up. What's Anthony think?
I think you're right.
You think our setup is okay? All right. We might need a calculator. These numbers are going to get pretty big. So we would start by distributing the 2. What's 2 times 67? 134. Sound about right?
Yeah.
All right, check me.
The math
Don't check.
calculation.
You need to check my mental math.
134.
Thank you. And then what's 2 times -8? Or 2 times -4 is -8. My brain was thinking faster than my mouth. All right. What would happen next? Who would we move? Jose? The -8. If it could come and join the 6, we could avoid negatives. So it's going to be 78 plus 14x equals 134. I'm running out of space. What has to happen next? Help me out with that calculation.
I shall do it in the calculation. It is 56.
Good. Divide by 14. Divide by 14.
It is 4.
4 years.
Oh,
So in 4 years, the new will be twice the used. If we did everything right. But I don't see anything we did wrong. Last one. It looks like we're talking about a gardening association. Listen up, last one. The membership fee for joining a gardening association is $24 per year. A local botanical garden charges members of the garden $3 for admission to the garden. Non-members are charged $6. After how many visits to the garden is the total cost for members, including the membership fee, the same as the total cost for non-members? All right, so we're going to have a member side of our equation, and we're going to have a non-member side of our equation. We want to know how many visits until they're going to be equal. What do we know about the members? How much do they pay? $24 to join. And then how much each time they go to the garden? $3 per visit. X will be how many visits. What about non-members? $6 each visit. They're not joining anything, so they don't have a base charge. Solving this should be a breeze. What would we do first? Subtract the 3. Sometimes people become members just to support the organization. You know, I'm a member of the Ohio Valley Giant Pumpkin Growers. Divide both sides by 3. So after 8 visits, it'd be the same cost for members and non-members. All right, you do know what your homework is tonight. 2.5 in the varsity learn, and if you didn't do the 2.4 over the weekend, you're gonna double up today. All right. So I will see you tomorrow. Thanks for watching the video, scholars.